Alright, Chapter 7, Metal Identification, Training Circular 9237. Section 1, Characteristics General. Most of the metals LHG from the Army material can be welded by one or more of the processes described in this manual. The section describes the characteristics of the metals and their alloys and the particular reference to the significance in the welding operation. Properties of metals. Definitions. All metals fall within two categories: ferrous or non-ferrous. Ferrous metals are metals that contain iron. Ferrous metals appear with the form of the cast iron, carbon steel, the tool steel. The various alloys of the iron are, after undergoing certain process with the pig iron, gray cast iron, white cast iron, malleable cast iron, right iron, raw iron, alloy steel, carbon steel. All of these types of the iron are mixtures of iron, carbon, magnesium, sulfur, silicon, and phosphorus. Other elements are also present, but in amounts that do not appreciable affect the characteristics of the metal. Non-ferrous metals are those which do not contain iron. Aluminum, copper, magnesium, titanium alloys are among these metals which belong to this group. Physical properties. Many of the physical properties of the metal determine how they can be welded and how they will perform in the surface. The physical properties of the various metals are shown in Table 7.1, page 772. And this shows the table physical properties of the metals. But alright, color. Color relates to quality light reflected from the metal. Mass density. Mass density relates to the mass of the respective of the volume of the common known of the specific gravity, the property of the ratio of the mass of the given volume of the metal of the mass. The same volume of the water is specified at the temperature, usually 39 degrees Fahrenheit. For example, the ratio of the weight of the 1 cubic foot of water for the 1 cubic foot of cast iron, and the specific gravity of the cast iron of the properties measured with the grams per cubic millimeter centimeter in the metric system. Melting point. The melting point of the metal and important for the regard of the melting, regard to welding the metal, feasible with the relate with the melting point with the temperature at which the metal changes with the solid, the molten state. The pure substance have sharp metal point pass with the solid state with the liquid without the change of the temperature for during this process. However, the absorption of the heat during the metal and liberation of the heat during freezing, the absorption of the release of the thermal energy of the surfaces. Substances change with the state called the Latin heat. Mercury is only one common metal with a molten state with a normal room temperature. The metals have low melting temperatures, can be welded with lower heat temperature. Heat sources soldering and bracing process that utilize low temperature metals to join the metals having higher melting temperatures. Boiling point is an important factor of the welding, with the boiling point with the temperature at which the metal changes with the liquid to the state of the vapor state. With some metals, when exposed to the heat of an arc, will vaporize. Conductivity. Thermal-electrical conductivity relate with the metal ability to conduct the transfer of heat and electricity, with the thermal conductivity with the ability of the metal to transfer heat, and those of the mass and visual importance. Thermal and electrical conductivity relate to the metal's ability to conduct and transfer heat and electricity. Thermal conductivity is the ability of metal to transmit heat through its mass and vital importance for the welding. Since one metal may transfer the heat from the welding or much more quickly than another. The thermal conductivity of the metal indicates the need of the preheating and the size of the heat source required. The thermal conductivity usually relates to copper. Copper has the highest thermal conductivity of the common metals, exceeded only by silver. Aluminum has approximately half the thermal conductivity of copper, and steel have about 1/10 of the conductivity of the copper. Thermal conductivity is measured with the calories per square centimeter per second per degree Celsius. Or electrical conductivity is the capacity of the metal to conduct the electrical current, with the measure of the electrical conductivity provided with the ability of the metal to conduct the passage of electrical current. Its opposite, resistivity, which is measured by the microohms of the per cubic centimeter for the standard temperature for the usually 20 degrees Celsius. With electrical conductivity is usually considered the percentage is related with the copper and silver. Temperature paired with important more parts of the property of the temperature. Metal increases the conductivity, decreases this, and property of the particular important for the resistant welding electrical circuits. Property of the metals continued. Coefficient of linear thermal expansion. With a few exemptions, solids expand with whether they are heated or contracted when they are cooled. The coefficient of linear thermal expansion is measured with the linear increase per unit length based on change of the temperature for the metal. The expansion of the increase of the dimension of the metal caused by the heat. The expansion of the metal with the longitudinal direction is known as the linear expansion. The coefficient of the linear expansion is expressed in linear expansion per length of the 1 degree temperature. With the increase of the metal increases the size of the increase not only in the length but also in breadth and thickness of it is called the volumetric expansion. The coefficient of the linear and volumetric expansion varies on the wide range of the different metals. Aluminum and the greatest coefficient with expansion, with expanding almost twice as much of the steel with the same temperature change. This is important important of the welding, the respect for the warpage control fixturing, and the welding together with the dissimilar metals. Corrosion resistance, resistant eating of the wearing of the way of the air and moisture of the agents. Mechanical property, the mechanical property of the metals determine range of usefulness of the metal with established surface with the can be expected for the mechanical properties of the also used to help specify with the identify with the metals. They are important to the welding, but the weld that must provide with the same mechanical properties for the base metal being joined with the adequacy of the weld depends on whether for them not provide with the property equal to exceeding with the metals of the being joined. The most common mechanical properties considered length, strength, and hardness, ductility, impact, or resistance. Mechanical properties of various metals are shown on the table 7.2. 7.2 shows mechanical properties of the base of the or alloy, yield strength in pounds. Pascals, kilograms, meters, and tensile strength, elongation, and hardness. Alright, tensile strength is defined with the maximum load with the tension material with the withstand with the fracturing ability with the material to resist the pull apart with the opposing factors. Opposing forces, also known as the ultimate strength with the maximum strength with the develop with the metal with the tension test. The tension test is a method to determine the behavior of the metal under actual stresses of loading. The test provided with the elastic limit, the elongation, yield strength with the yield tensile strength with a reduction in the area. Tensile strength is the value of the most common given with the strength of the material with given in pounds per square inch of the kilopascals. Tensile strength is the number of the pounds force required to pull apart with the bare metal with 1 inch wide and 1 inch thick. Shear strength is the ability of the material to resist the being fractured opposing forces acting in a straight line, but not in the same plane with the ability of the metal to resist the fractured opposing forces not acting on a straight line. So tensile, figure 7.1 shows the tensile strength, 7.2 shows shear strength, and properties of the material. Fatigue with the strength with the maximum load of the material can withstand with the failure during the large number of the reversals of a load. For example, the rotating shift of the wheel support with the wave with the has the tensile force with the top portion with the shaft with the compressive force with the bottom shaft that's rotated. There is a repeated cycle with the change with the tensile with the compressive strength with fatigue strength values as are used in the design of aircraft strength with swings and other structures subject to the rapidly fluctuation load with the fatigue strength with the influence of the microstructure, surface condition, corrosive environment, and cold work. Corrosive compressive strength with the maximum load with the compression with the material will withstand with a predetermined amount with the deformation ability with the material will withstand pressure acting on a given plane with the compressive strength of both cast iron and concrete are greater than the tensile strength than their tensile strength. For most material, the reverse is true. Elasticity is the ability of the metal with the term of the original shape, size, shape, and the dimension of the being deformed and stretched and pulled out of the shape. The elasticity of the point with which to determine the damage start with the yield of the point with the definite damage occur with little or no increase with the load with the yield strength with the number of the pounds per square inch or kilopascals it will take for the produce the damage of the deformation at the yielded point. Modulus of elasticity. Modulus of elasticity with the ratio of the internal stress of the strain produced. Ductility of the metal with the property of the allow with the woody stress of the otherwise change with the shape of the without breaking with the retaining of the change with the shape of the after the load with has been removed is the ability of the material such as copper to be drawn with the stretch of the permanently without fracture, the ductility of the metal with the determinant of the tensile strength with the determinant of the percentage of elongation, the lack of the ductility, brittleness of the lack of showing any of the permanent damage before the metal cracks or breaks as such as the cast iron. 8. Plasticity. Plasticity is the ability of the metal to deform extensively without rupture. The plasticity is similar to the ductility. Malleability is another form of the plasticity in the same with the ability of the metal to deform permanently with the under compression without rupture. It is the property of the allow of the hammering of the rolling of the metals into thin and sheets. The gold, silver, tin, and lead are examples of metals exhibiting a high malleability. Gold has exceptional malleability and can be rolled into sheets thin enough to transmit light. Reduction area. The measure for the ductility is obtained with the tensile strength, tensile test for the measure for the original cross-section area with the specimen with the cross-sectional area with the failure. Brittleness is the property of the opposite of the plasticity. The ductility of the brittleness of the one of the cannot be visibly deformed and permanently with the one of the lacks plasticity. Toughness is the combination of the high strength of the medium ductility of the ability of the material, the metal, with the resist of the fracture, plus the ability of the reset of the failure for the after the damage has begun with the tough metal with the such as cold chisel is one of the wood to stand with considerable stress allow slowly suddenly applied which is deformed before failure of the toughness is ability of the metal to resist the start of the permanent distortion plus the ability to resist shock and absorb energy. Machinability and weldability, the property of the machinability, weldability easily difficult with which the material can be machined or weld. Abrasion resistance, the resistance of the wearing by friction, impact resistance of the metal with the impact with the elevated evaluated in terms of the impact strength of the material. The metal may be possess a satisfactory ductility under static loads, but may fail under dynamic loads or impact strength of the metal with the determined measuring the energy absorbed in the fracture. Hardness is the ability of the metal to resist penetration wherever another metal with a material will take. The combination of the hardness and toughness to withstand heavy pounding. The hardness of the metal limits the ease of the without, then can be machined. The toughness decrease with the hardness increase with the table 7.3 and the page 7.8 with it illustrates the hardness of the various metals. Brittleness hardness testing with the test of the hardness steel ball over the press and slowly with a known force against the surface of the metal to be tested. The diameter of the surface of the beam is measured with the brittle hardness number of the BHN. Determined with a standard table of the table 7.3 with the page 7.8 with the Rockwell hardness test of the test is based upon the difference between the depth of the width of the test point with the driven with the metal with a high light load and depth of the width with the driven with by light load heavy load. The light load is first applied without moving the piece, and the heavy load is applied with the hardness, and then the heavy load is applied with the hardness of the number that automatically indicated with the on the dial. Letter designation of the Rockwell scale, such as B and C, indicate that the penetrator issued as the amount of the heavy load. The same light load is always used. Your scale screw rope hardness test measure the hardness of the leading of the diamond tipped hammer falling by one weight of the fixed height of the rebound from the surface of the rebound measured on the scale of the use of the smooth surface of the where dense are not desired. 7.2 shows the properties of metal. Alright, 7.3 categories of metal. Continual, general. And necessary for the known with the composition of the metal being welded in order to produce the successful weld of the metal workers must be able to identify the various metal products and proper work methods may be applied with the Army equipment drawings. MWOs should be available to most be examined in the order of the determinant of the metal to be used with the heat treatment if required. After some of the practices, the welder will learn to certain parts of the machine of the equipment are always cast iron, other parts of the usually forging and so on. There are 7 different tests that can be performed in the shop to identify with the metal. 6 of the different tests are summarized with the table 7.4, page 710. These should be supplemented with the table 7.2, 7.1, 7.2, and page 7.2, 7.4 with the physical of the mechanical properties of metals, table 7.3, which presents the hardness data of the tests as follows, and it shows the appearance test. If the appearance test includes such things as the color of the appearance of the machine with the unmachined surface of the form and shape of the definite, includes with identified metal with the shape of the descriptive for the example shall include with the such of the things as cast iron block automobile bumpers, reference rod within I-beams, angle iron, engine block for the automobile bumpers, reinforcement rods, I-beams, angle iron, pipe fittings, form should be considered with the may show with the part of the road, such as the casting of the object, for the surface appearance of the melting, parting of the mold lines with the hot rolled wear through wrought material, extruded with the cold roll with a smooth surface. With an example, the pipe could be cast, in which the case it would be cast iron wrought, and would be normally be the steel of the color provided with the various strength of the clue with the metal demarcation, distinguishing many metals such as copper, brass, and aluminum, magnesium, precious metal. With the metals of the oxidized, the oxidation can be scraped off with the term of the caper color of the oxidized metal with the helps of identify the lead with the magnesium with even with the copper with the oxidation on with the steel with the rust with the usually clue that can be used to separate the plane with the carbon steel with the form of the corrosion resistant steels. Fracture test. Some of the metal will quickly identify with the locking of the surface of the broken part with the studying with the chip to produce the hammer with the chisel with the surface will show with the color of the base metal without oxidation. This will be true with the copper, lead, and the magnesium, and in other case for the coarseness of the roughness of the broken surface to indicate of the structure. The ease of the breaking part of the indicate the ductility, lack of the ductility. If and then the piece bends easily without breaking it, one or more of the ductile metals. If the breaks with little or no bending is one of the brittle metals. Spark test. Spark test is a method of classifying steel with the iron according to the composition, observing the sparks formed with the metal with the idle against the high speed with the grinding wheel of the test does not replace with the chemical analysis of the very convenient fast method of sorting mixed steel whose spark characteristics are known when held lightly against the grinding wheel the different kinds of the iron and steel produce the sparks varying length, shape, and color. Grinding wheels should be run with a surface speed of at least 5,000 feet per minute with a good spark stream. Grinding wheels should be hard with enough to wear with a reasonable length of the time just yet soft enough to keep the free cut with the edge. Spark testing should be done with a subsidized light with a sense of the color of the metal of the spark is important. In all cases, the base of the best use of the standard samples of the metal for the purpose of comparing the sparks with that of the test sample. Spark testing is not so much for the used on non-ferrous metals such as the copper, aluminum, and nickel-based alloys, since they do not exhibit the spark stream of any significance. However, there is one way to separate the ferrous and the non-ferrous metals. Alright, categories of materials continue. B. The spark result of the test should be directed downward and studied with the color, shape, and length of the activity of the spark will relate with the characteristics of the metal being tested with the spark stream specific item of the car. Which car can be identified with a straight line called the carrier lines. Usually with a solid continuous at the end of the carrier line with divided into 3 short lines and forks. Spark stream is divided into more than lines, and the end of called the sprig. Sprigs are curved with a different place of the carrier line. They're called either star or fan bursts. The some of the cases of the carrier line enlarging, slightly very short length of the continue with the perhaps enlarging again for a short length of the very heavy portion of the curve at the end of the carrier line, which could called spear points of the buds for the high sulfur created for the thicker spots of the lower carbon steel of the most alloys. Have relatively low stream. Steel usually has a white-yellow color spark, which white cast irons are reddish to straw yellow, and 0.15 hundredths of percent carbon steel shall be shin sparks of long streaks with some tendency to burst with a sparkler effect. Carbon tool steel exhibits with a pronounced bursting with the steel within 1% of the carbon shows brilliant minimum explosion with the sparklers and the end of the content. As the carbon content increases, the intensity of the bursting increases. Or one big advantage of the test is that it can be applied with the metal with the alternative with the bar stack with the racks and machine forgings and finish the parts with the spark test with the conduct with the holding with the test steel test stationary touch with the touching with the high speed with the portable ground with the specimen with the sufficient pressure for the throw with the horizontal spark stream with about 12 inches long, right angles of the line with the vision with the pressure for the gain for the work. It is important for being increasing the pressure of the wheel rate, the temperature of the spark stream, given the appearance of the higher carbon content. The sparks are near around the wheel with the middle with the spark with the stream with the reaction with the incandescent particles at the end of the spark stream that shall be observed with the sparks reduced with the various metals are shown in figure 7.4. 7.4 shows the characteristically generated with the grinding of the metals. And figure table 7.5 shows the summary of the spark test. And alright, caution. The torch test should be used with a discretion of the mid-ambits of the part of being tested. Additional magnesium may ignite when heated in an open test atmosphere. Torch test. Oxyacetylene torches welder can be identified with variously metals with the studying how the fast of the metal melts, puddle of the molten metal, and slag locks. Slag looks as well with the color change during the heating of the which sharper corner of the white metal with the part is heated, but the rate of the melting can be identified with the material with the aluminum will not melt it until sufficient heat has been used because it is high conductivity. The part of the zinc, the sharp corner will melt quickly with the sense that the zinc is not a good conductor. In this case, the copper, if in the sharp corner, in this case, the copper, if the sharp corner melt with the normally deoxidized copper. If it does not melt until the much heat that has been applied with electrolytic copper. Copper alloys are composed of the lead of the wheel boil with the distinguished aluminum with the magnesium. It will apply with the torch with the fitting of the magnesium will burn with the sparkling white flame with the steel will slow characteristic of the color before the melting. Your magnetic test. The magnetic test can be quickly performed using the spark by a small pocket magnet with the experience of the possible with the judge with a strong magnetic material with a slightly magnetic material with a non-magnetic material. Is easily recognized with the strong magnetic material include carbon and low alloy steels, iron alloys, pure nickel with the magnesium stainless steels. Slightly magnetic reaction is obtained with the mono high nickel alloy stainless steel of the 18 chromium 8 nickel type with the cold worked with a stainless steel with a non-magnesium material with a copper base alloy with aluminum base alloys doing base alloys and yield 18 chrome 8 nickel stainless magnesium precious metals. Chisel test. The chip of the test for the chisel test may be used to identify with the metal. With the only tools required with the banner of the cold chisel, the use of the cold chisel, the hammer, the edge of the corner of the material being examined, and the ease of the production producing the chip is an indication of the hardness of the metal. If the chip is continuing with the identification of the ductile metal, whereas the chip breaks apart and indicate with the brittle material. On such materials common with aluminum, mild steel, malleable iron chips are continuous. These are easily chipped. The chips do not tend to break apart with the chips of the gray cast iron so bright that they become small broken fragments on high carbon steel. The chips are hard to obtain because the hardness of the material can be continuous. Alright, hardness test. Referable. Table 7.378 with the hardness value of the various metal with the page 7.7 and the information for the three hardness tests that are commonly used with the test process of the hardness test of the file test. A summary of the reaction of the filing, the approximately barrel test, and the possible type of the steel with the shown figure of table 7.6. Sharp mill file must be used and assumed if the part of the steel of the file test will help identify the type of the steel. 7.6 shows approximate hardness of the steel by the file test. Chemical test. Numerous chemical tests can be made in the shop to identify the term of the material with the distinguished with the inconel 1 drop of the nitric acid applied with the surface of the term with the blue with the green model will show no reaction with the inconol. If you drop it to 45% of the phosphoric acid will bubble up low chromium stainless steel with a maximum with the distinguished aluminum using silver and nitrate with the will leave black deposit for the magnesium, but not on aluminum. The test can become complicated for the reason of not detailed further here. Color code marking steel bars. The Bureau stands for the United States with the Department of the Commerce for the color coded marking steel bar with the color marks of the provide with the code with the may be applied with the painting of the end of the bars with the solid color with the usually mean carbon steel with the twin colors designated alloy and free cutting steel. Ferrous metal, the basic substance that become used to make with the bowl steel with the cast iron with the grade malleable as iron used for the form of the pig iron with the produce of the iron ore with the occur of the chiefly of the nature of the oxide of the two most important oxides being hermite and magnetite with the iron ore reduced to the big iron in a blast furnace and priorities are removed with the form of the slag. Figure 7.5, page 716. Raw materials chained with the furnace include with the iron ore, coke, limestone, and the pig iron include produced used for manufacturing steel and the cast iron. Plain carbon steel consists of iron and carbon. The carbon hardening element for alloy steel contains the elements of the chromium, nickel, molybdenum. Cast iron is nothing more than basic carbon steel with more carbon added along the silicone. So the carbon content range from 300 to 1.7% of the 4.5% in cast iron. Alright, categories of metals continue. Steel is produced with a variety of the melting furnaces with the open heart with the Bresmere with the converter with the crucible, electrical arc, induction, most carbon steel with the base with the open heart with the furnace, while alloy steel is melted with the electrical arc, induction, and furnaces. Raw materials chained with the furnace include with the mixture with the iron ore, pig with the iron limestone with the scrap. After melting that has been completed, steel is taped and from the tapered from the furnace with the ladle with the poured with the ingots of the patterned molds. The ingot is used with the large rectangular bars, which are reduced rather than rolling operation. The molds are used for casting. And this shows a blast furnace. Our cast iron is produced with the melting of the chain with the pig iron with the limestone with the coke with the copula furnace with the pour with the into sand alloy steel molds. We'll make it with the gray cast iron with casting with the molten metal with the mold with the slab with the become with the solid with the cool with the room temperature with the open air with the malleable cast iron with the other hand with the made with the white cast iron with similar in content with the gray cast iron except for the moldable iron contained with less of the carbon and silicone with the weight cast iron is any with more than 150 hours temperature range with 1500 to 1700 degrees Fahrenheit to 1700 degrees Fahrenheit. The result is produced with called with the malleable cast iron with the desirable property of the cast iron less than those carbon steel with produced with the difference of the chemical makeup of the structure. Carbon present with the hardened steel with the solid with the solution with the white cast iron contained with the carbon known with the graphite within gray cast iron with the graphite with the flake form with the malleable cast iron. Graphite is nodular rounded form. There is also count with the higher mechanical property of the malleable cast iron compared with the gray cast iron. Iron ore is smelted with the coke with the limestone with the blast furnace with the remove of the oxygen and the process of the reduction of the either form matter from the limestone is combined with the earth matter to form a liquid slag. Coke is used to supply with the carbon needed for the reduction of the carbonization of the ore. The iron ore and limestone with the coke are charged at the top of the furnace with the rapid combustion with the blast of the preheated with the smelter caused with the chemical reaction during which the oxygen removed the iron and the iron melts with the molten slag with the existing of the limestone flux ash of the core together with the compounds formed with the reaction of the flux and substance present with the ore with the flow time. The heavier iron liquid each material then is then drawn separately. Figure 7.6, page 718. All forms cast iron steel with the wrought iron consists of a mixture of iron and carbon. Other elements, small amounts. Well, the metal is cast iron steel, but it depends entirely upon the amount of carbon in it. The figure 7.7 shows this principle. Table 7.7 the carbon content with the cast iron and steel. Cast iron differs with the steel mainly because of the excess of the carbon, more than 1.7%, with it distributed throughout the flake of the graphite, causing most of the remaining of the carbon of the steel to separate the particle of the graphite with the pass through the will fissure with the occur with the reason for the cast iron with is brittle with the by carefully for the control of the silicone content with the rate of the cooling it is possible to cover the definite amount with the carbon to separate with the graphite to remain combined. The white and gray malleable cast irons are also produced with a similar base, and this figure shows the conversion of the iron into cast iron, wrought iron, and steel. Alright, wrought iron. General wrought iron is almost the pure iron, but it's made with the pig with the iron, with the puddling with the furnace, with the has with the carbon content less than 800% with the carbon and other elements with the resin with the pig iron, with the taken out with leaving the more almost pure iron. In the process of the manufacture with the slum slag with the make for the iron to form with the fibrous structure of the long stringers with the slag running lengthwise as mixed with the long threads of the iron. Because of the strength of the presence of the slag, wrought iron resists corrosion and oxidation will cause rusting. Use wrought iron is used for the porch railing, fencing, farming implements of nails, barbed wire, chains, modern house hold fixtures and decorations. Capabilities: wrought iron can be gassed with the arc welded, machine plated, and easily formed. Limitations: the wrought iron has low hardness and low fatigue. Strength properties: wrought iron is a brittle hardness number of 105, the tensile strength of 35,000 pounds, specific gravity of 7.7, the melting point of 22,750 degrees Fahrenheit, and then the ductility with the corrosion resistance. Appearance: the appearance of the wrought iron is the same as those of the rolled load carbon steel, with the fracture tip of the wrought iron and fibrous structure due to threaded slag with the result that can split with the direction which of the fiber of the run with the metal with the soft, easily cut with the chisel with the quiet ductile with the nicked and bent with is like rolled steel with the how with the break of the jagged due to the fibrous structure of the wrought iron cannot be hardened. Spark test: when wrought iron is grounded, the straw-colored sparks from Near's grinding wheel change with the white and forked sparklers near the end of the stream. The torch test: wrought iron melts quickly without sparking, but the holes of the particular slag coating with the white lines and oily, greasy appearance. Cast iron: gray, white, and malleable. General: cast iron, man-made alloy of the iron, carbon, silicone portion of the carbon exists with the free carbon, the graphite. The total carbon content with it is between 1.7 and 4.5%. Users: cast iron with the use of the water pipe with the machine tool casting with transmission housing, engine blocks, pistons, stove casting, etc. Capabilities: cast iron may be brazed with the bronze welding, gas for the arc welding, or hardened in machine. Limitation: cast iron must be preheated prior to the welding if it cannot be worked with cold. Properties: cast iron had the brittleness number of 150 to 220, no alloys, 300 to 600 alloyed, tensile strength 25,000 to 50,000 psi, and 50,000 to 100,000 psi to 689,000 and a half kilopascals. Alloyed specific gravity 7.6, high compressive strength with the 4 times the tensile strength with a high rigidity with a good wearing resistance, fair corrosion resistant. Gray cast iron, the molten pig iron for the primitive with the slowly, carbon cools slowly, the chemical carbon iron with the carbon breaks up to a certain extent with much of the carbon, separated with the flake with the graphite scattered throughout with the metal with the graphite, but like carbon, distinguished with the carbon content causes the gray with the appearance of the fracture with the characterized with the ordinary gray cast iron with the tinge of the graphite. It is excellent lubricated with the metal with the shot through tiny, flaky cleavages of the gray cast iron with easy the machine with can be withstand heavy shock with the gray cast iron consider the 90 to 94% with the metallic iron with a mixture with the carbon content with the magnesium sulfur silicone special high strength with the gray with the metal with the contains 0.75 to 1.5% of the 0.25 to 0.5% with the chromium 0.25 to 1.25% molybdenum medium commercial grade with 2.5 to 4.5% carbon all and about 1% of the carbon is combined with the iron, while with is about 2.75% of the remaining 3 with the graphite state, and making of the gray cast iron with the iron with the silicone content with the usually increased the sense of allowed with the formation with the graphite carbon combined carbon iron carbide with which is a small percentage of the total carbon with the present with the cast iron with the known with the cementite is known as cementite. In general, with the more free carbon with the graphite carbon presented with the cast iron lower combined with the carbon content of softer iron. Appearance step of the unmachined surface of the cast iron with the casting with the bold dull gray with the color with the some of the roughed and sand with the molded you with the casting part of the casting iron castings and roughly machined all over the unmachined casting with the baby ground with the plate with the remove the rough edges fracture tip and nick with the corner with it all around with the chisel with the hacksaw with the triangle with the corner with the sharp blow with the hammer the dark gray color with the broken surface of the cup with the fine black specks with the carbon present with the form with the graphite with the cast iron breaks short with the when fractured small and brittle chips made with the chisel break off with the shown with the form the spark tip with the small volume with the dull red sparks will follow a straight line closing with the wheel with the given to the wheel given off with the metal with the spark tip with the brakes off with the many fine repeated spurs to change the straw color. Torch test. The torch test resolve with the molten puddle with the molten metal with the quietly jelly-like consistency with the torch will flame with the raise with the depression with the surface of the molten puddles disappear instantly with the heavy with the torch film forms with the surface of the metal with the molten pedal takes time with the hardened with the gives off no spark. White cast iron. When gray cast iron is heated with the molten metal state, the carbon complete with the dissolve of the iron with the properly with the combined with the chemical with it chemically with it and the molten metal with the cool quickly the two elements remain in the combined state with the white cast iron form of the carbon and the type of the iron measured for the 2.5 to 4.5% of the weight with the referred to with the carbon content combined carbon and white Cast iron is very hard, brittle, with the imposable machine with a silvery white fracture. Malleable cast irons. Malleable cast irons are made with the heating of the white cast iron with a 14 to 1700 degrees for about 150 hours. The box with the contained with a hermite or iron scale with the heating cloth with the part with the combined with the carbon with the chain with the free with the uncombined state with the free with the carbon separated with a different way with the carbon gray cast iron is called temper carbon. It is exists with the form with a small round particle with the carbon with the gray ray. Give malleable iron with the casting with the allowable ability to bend before breaking and withstanding shock better than gray cast iron. The casting with the property for the more like with the pure iron with high strength of the ductile strength with the toughness of the ability for the resist shock. Malleable cast irons can be welded to the braces of any of the welded parts of a needle before welding. Appearance of the surface of malleable cast iron is very much more like gray cast iron, but is generally free of from sand, the dull gray, and somewhat lighter color than gray cast iron. Fracture test: malleable cast iron is free fracture certain points of the broken surface of the dark gray with the brittle straight steel-like band of edges. The appearance of the fracture might maybe best be described as a picture of the frame. When good quality of the malleable cast iron is much tougher than the outer cast iron that does not break short when nicked. Spark test: when malleable cast iron is grounded, the outer brighter layer gives off brighter sparks like steel. As the interior is reached, with the sparks quickly change with a dull red color around near the wheel. These sparks from the interior of the section vary much like those of the cast iron. However, they are somewhat longer and present in large volume. All right, 4. Torch death. The molten metal cast iron is boiled to the under of the torch with the flame. After the flame has been withdrawn, with the surface of the flow blow holes with the fracture melted parts, very hard, brittle, and having appearance of the white cast iron, where they have been changed with the white, with the chill, with the iron, with the melting, with the fairly rapid coloring. Outside bright and steel-like bands give off sparks, and the center does not. Steel, general, a form of an iron with iron. Steel contains less than carbon content than cast iron. More be considerable more with the raw iron with the carbon content with 300 to 1.7% of the most carbon steels are alloyed with other elements such as the chromium and nickel to increase the certain physical properties of the metal. With the use of the steel, we use the nicks, nails, rivets, the gears, structural steel, roll decks, hoods, fenders, chisels, hammers, etc. Capability steels can be machine welded, forged at all varying degrees depending on the type of the steel. Limitations: high oil, difficult to produce. Properties: steel has a tensile strength of 45,000 psi for the low carbon steel, 80,000 psi for the medium carbon steel, 990,000 for high carbon steel with 115,000 psi for alloyed steel with a melting point of 2,800 degrees Fahrenheit. Low carbon steel with a carbon content with up to 0.3% of the steel with the soft with the ductile can be rolled with the punch with the sheared worked with either hot or cold with the easily machined with it can be readily welded with old methods, and it does not harden with the greater any of the greater amount. However, they easily can be hardened. Appearance test depends upon the method of penetration rather than upon the composition. Cast steel is relatively rough, dark gray with the surface except for that it has been machined. Rolled steel is fine. Surface lines running in the one direction. Forged steel is usually recognizable in the shape of the hammer marks and fins. Fracture test: when low carbon steel with the fracture with the color with the bright and brittle crystalline gray with the toughness of the chip of the nick with the low carbon steel with the bright iron, raw iron and steel castings cannot be hardened. Spark test: the steel gives off the sparks with the yellow orange streaks brighter on the cast iron with the show with the tendency with the burst of the white forked sparklers. 4. Torch test: the steel gives off the spark when melted and the hardens almost instantly. Medium carbon steel, carbon content ranging from 300 to 500% with the steel with the be heated with the treated with the 30 hundredths or 50 hundredths of a percent. The steel might be heat treated with the fabrication used with the general machining with the forging of the part with the required with the strip of the hardness of the strength with the made with the bar form of the cold rolled normalized annealed condition during the weather with the welded zone with the become hardened with the cool with the rapidly with the must be stress relieved after welding. High carbon steel with a carbon content ranging from 0.5 to 0.9%. Steel is used for the manufacture drips, tabs, dies, springs, and other machine tools with the hand tools that are heat treated with after fabrication developed with a hard structure necessary to withstand high shear stress and wear. It is manufactured with a bar sheet with the wire forms and needle with the normal conditions in order to be suitable with the machining before the heat treatment with the steel is difficult to weld because of the hardening effect of the heat with the welded joint. Appearance definitely unfinished surface of the high carbon steel is dark gray and similar to the other steel, with the more expensive, the highly usually work to produce smooth surface finish. Your fracture test: high carbon and steel usually produce a very fine grade fracture, whereas low carbon steel with the tool steel is hard, more and brittle than plate steel with low carbon material. With a high carbon steel can be hardened by heating a good red quenching in water. Spark test: high carbon steel gives off a low Large volume, bright yellow orange sparks. The torch test, molten high carbon steel with the brighter than lower carbon steel with the melting surface with the pores appearing with the sparks more with the freely with the low carbon mild steel with the low sparks are whiter. High carbon steel testing. High carbon tool steel with the carbon content range from the 0.9 to 1.55% used with the manufacturing chisel with a shear blade with the cutters with a large tap of the wood and turning tool with blacksmith tool with razor with similar parts where the hardness of the high hardness is required with the machine maintain a sharpening cutting edge for the difficult of the weld due to the high carbon content of the spark test should be moderately large volume of the white sparks having many fine repeating bursts. All right, cast steel. Generally, welding difficulty with the steel casting converting containing over the 0.30% carbon and 0.20% silicone. Alloy casting steel containing nickel molybdenum, be it barium. Both of these metals are easily weld with the carbon content of the low with the containing with the chromium, the vanadium, with the more difficult with the weld with the sin of the magnesium steel with nearly always with the form of the casting with the also consider with the cast steel with the high resistant wear with the most valuable property. Appearance of the test with the surface of the cast steel with the brighter than the cast of the malleable iron sometimes contained with a small bubble-like shape depressions. Fracture shape of the color of the fracture of the cast steel is bright with the crystalline gray with the steel with the tough and does not break short. Steel castings are tougher than malleable iron. Ship is made with the chisels curl up more, and magnesium steel, however, is so tough that it cannot be cut with a chisel, nor can it be machined. All right, spark test. Spark test grade with the cast steel with the machine with the brighter with the cast iron. The magnesium steel gives off with more marks of the explode with throwing with the brilliant sparkers. Right angles original path of the spark. Heat torch test. When melted, the cast steel spark with the hardens quickly. Steel forging. General steel forging made with the carbon alloy steels. Alloy steel forgings are harder with more brittle with the low carbon steel with appearance test. Surface of steel forgings is smooth with web, but the surface of the dropping forgings have not been finished, but will be evidence of the result of the melting, squeezing or between the two forging dies and removed from the trimming of the dies enough to shear with the surface of the remain from the identification. All forgings are covered with a red, brownish, black scale unless they have been purposely cleaned. All right, fracture test. The color of the fracture for the steel forging vary with from the bright crystalline with the silky gray with the chips over the top with the sample with the nick with the harder break of the cast steel with the finer grain with the forgings maybe below with the high carbon steel with the alloy steel with the tool steel hard more brittle than the thin plate steel with the other low carbon material with the fracture is usually whiter finer grade. Tool steel become hard with the heating of the good bread and quenched in the water. Low carbon steel with the wrought iron with the steel cast iron cannot be usually hardened. Usefully hardened. Spark test with the sparks given off along with the yellow-orange stream of the typical steel spark. With the sparks are high carbon steel with the machinery with the tool are brighter than those of the low carbon steel. With the torch test, steel forging spark the melted sparks increase over the number of the brittleness of the carbon content and becomes greater. All right, alloy steel. General alloy steel is frequently recognized with the use of the many variety of the alloy steel of the manufacturing arm and equipment of the greater with the strength with the durability with the carbon steel with the given the strength with the secure with the less material weight with the magnesium steel with the special alloy steel with the usually used in these casting conditions. See cast steel page 723. Nickel, chromium, the vanadium, the tungsten, molybdenum, silicone are most common the elements of the alloy steel. With the chromium is used with the alloy elements with the carbon steel with increased with the hardenability with the corrosion resistant, shock resistant in parts with the high strength with the little loss of the ductility. Nickel increase with the toughness of the strength with the ductility of the steel with the lower with the hardening temperature. So for the oil quenching with the rather than a water quench is usually useful for hardening. Magnesium range used in the steel with the produce with the greater toughness of the wear with the resistant. Easier hot rolling or forging. Increase with the magnesium content with the decrease with the weldable steel with the molybdenum. Increase with the hardening ability, which is the depth of the hardness the possibility with the heat treatment with the impact with the fatigue property of the steel with the improved with up to 0.60% molybdenum above 0.6% molybdenum. The impact fatigue property is impaired with the resistant improved with the molybdenum content with above 0.75% with the volume. Molybdenum is sometimes combined with the chromium, tungsten, vanadium, and other desired properties. Titanium and columbium or niobium is used with the additional alloys with the low carbon content corrosion resistance of the support, the resistance of the intergranular corrosion after the metal is subject to the high temperatures for a long time period. Let's see how many more pages we got. All right, we're gonna cut the tape there.